Hello everyone and welcome to the third topic in the SS1 physics curriculum. Now, in this topic, we'll be looking at position, distance, and displacement. Now, if you're seeing this video for the first time, welcome to our page where we discuss different topics in the curriculums of your classroom subjects. On our page here, you'll find different videos on different subjects. This is a video on physics, and this is for the SS1 curriculum. This is the third topic. So on the page, you will find videos from the other topics that have been discussed. So please do well to check them out. And don't forget to subscribe to the channel and click the notification bell icon. So this way, every time we put out a new content, you will always be notified. Now, as I said, in this topic, we're looking at position, distance, and displacement. Now, what is expected of every SS1 student when you take this topic is what we have broken down here into bite-sized subtopics so that you can then get to understand it in full. So firstly, we'll be looking at the meaning of position. At this point, you should be able to define what position is in physics. Now, we don't look at it as just a word. We look at it how it can be defined from the physics perspective. Don't forget that in physics, we are looking at matter and its relationship with energy. So we look at how you can define the position of an object in physics. And the next thing there also goes in line with this. You should be able to learn how to represent or to read an object position. So for example, in physics, you'll be solving questions that requires you to identify the position of an object, or when you're solving questions related to distance or displacement and the likes, you could be given the positions of those objects. So it is expected that you should be able to read off that, give it a meaning, and then use it to solve that problem. So that will be what you'll be doing at this level. Now, the third thing we'll be doing is to find the meaning and characteristics of distance. So it's not enough that you define distance, you should be able to tell the characteristics of distance and also be able to tell the meaning and characteristics of displacement. Now, oftentimes students kind of mix this up. They usually replace distance with displacement or displacement with distance. So it's important that we're able to tell the difference between them. So when we've been able to identify this, then we'll go on a task where we'll then pick out the key differences between distance and displacement. So at that point, we will now be able to tell the distinctive differences between them so that you don't mix them up any longer. And then to end it, we'll then look at solving problems on position, distance, and displacement. So at this point, we begin to look at different problems on this topic from the WAEC, from JAMB, and other exam bodies. And then we'll pick out these questions, we solve them step by step so that you understand the process that it takes to solve this kind of problem. So I would like you to follow the video from start to finish. Trust me, it's going to explain everything in more detail and you don't want to miss any bit of this video. And please don't forget to also share the video so that every other person who are in need of content like this can also get them. So we don't know, those on your list might also be needing this video. So please help us by sharing the video and also encourage them to like, share, and subscribe. So if you're ready, let's begin to look at these different subtopics, starting with the meaning of position. Let us look at the meaning of position. Now, when we're looking at position, we're looking at it from the perspective of physics. That is, what does physics define position as? Now, many times we just say it is defined as the point where an object lies in space, but this is not enough to define it in physics. Now, to break this down, take for example, if you have an object, say a heavy stone that is along your pathway. Now, that stone can be a danger to you because there is the tendency that you might hit that stone along that path. But it's a different situation entirely if that stone were behind you on the path. Now, because you are moving forward, there is no way you would hit a stone that is behind you, right? So you see that energy is also tied to position, and that is what physics is really looking at. So we don't just look at the point in space where an object is, we define it by the path it is, the direction it is, and with reference to another object. So if we want to define position now, in terms of physics, this is what you would say. You say the position of an object is in space is defined as the distance of that object from a reference position. Or to put it in another way, you say the distance of that object from a point called the origin. Now that origin could be any point entirely, but in physics it is marked 0,0 as coordinate. Okay, so when you look at an object and you measure the distance from that object to a reference point that could be your origin in this case, then you have defined the position of that object. And it's important to also mention at this point that when measuring this position of an object, it could be in a one-dimensional space, a two-dimensional space, three-dimensional space, and so on. So that tells you that it is a vector quantity. So it has both magnitude and direction. Now, before we progress, let us write this definition out. So we say position of an object, or let me say the position. The position of an object in space is defined as its distance from a reference point. So let's just say called origin. So when you look at the position of an object, you are looking at how far it is from a reference point, whether on the x or y axis, as the case may be, depending on the number of dimensions in that space. So this is how we would define the position of an object in physics. So now the next thing we'll be looking at is how you can then read off the position of an object, or how you can represent the position of an object in physics. Now let us learn how the position of an object is represented in physics. Now before I go into the details of how we do it in physics, I will first explain the concept of representation of a position to you. We'll use different ways to explain it so that you can quickly understand what we mean by representation of position. And if you're yet to like the video, please take a moment to click the like button. And also, if you are not subscribed, ensure that you hit the subscribe button. And please don't forget to share this video. You just might be helping someone learn more about this topic. So please share the video and encourage them to like, share, and subscribe as well. Now, when we're looking at the position of an object, we've already defined it as at the distance of that object from a reference point, right? So take for example, if you're on a street, if you're asked to visit someone and the person tells you, I live on 25 Crescent Avenue or 25 Moon Avenue, let's just use something like that, something random, okay? Now, that street itself is a linear path. In physics, we call that a one-dimensional plane, right? So along that street, you will have different houses and they bear their house number, right? So as you walk along that, all you need to check out for is the number, right? You have numbers from 1 till infinity along that street. So if the person lives on number 10, for example, you have to pass the first 9 houses before you get to that person's house on that street. So you see that number 10 there, describe the position it is along that one-dimensional plane. Okay, now this is not exactly how it is in physics, but it kind of gives you a picture of what we are talking about. Now, if someone were to visit you in your classroom, right, and this person does not know you, does not know what you look like, does not know what you sound like, or anything about you. Now, in your classroom, there's a possibility that it is arranged in rows and columns, isn't it? So now, if the person is coming to your classroom and wants to identify you, immediately steps in. It can get you by your row and column number. So let's say we have this arrangement. This is in rows and columns. As you can see here, we have 4 rows and 4 columns. Now let's assume you are seated at this particular seat. Now the person is going to be able to identify you if you tell the person that when you get into the class, let's say this is the entrance of the class, right? And then you tell the person, I sit on the third row and also on the third column. So once the person comes in, he's able to identify this as row 3, column 3. Now you see this, that he uses two things to identify where you are exactly, the row and the column. This looks at it from the two-dimensional space. So when you are defining position from a two-dimensional space, you need two numbers to identify how far you are from two reference points, from a reference point, not two, from one reference point. The reference point is the entrance here. So the person has to move from the entrance 3 rows down and 3 columns the other way, right? So that way identifies where you are. We are still talking position here. Now remember I mentioned that when we are talking about position in physics, it could be in 1 dimension, 2 dimension, 3 dimension, and so on like that, okay? So I would just stop at the 3rd dimension part. So when we are saying 3rd dimension, now the person does not only look at 2 directions, he also looks at the height, so the length, breadth, and height. Say for example now, the object is hanging from the ceiling, okay? Now when the person steps into the class, he has to move 3 rows, 3 columns, and then have to go up to get where it's going. Or for example, if your class is, let's use your classroom on maybe the 3rd floor of a building, okay? So if it's at the 3rd floor of the building, the person first has to go up, then has to move the direction, a length in another axis, and then the 3rd length. So you see there we have 3 distances that we have to define to get the position of that object. That will be you defining the position of an object from a 3-dimensional space. So using all of this, we can say to represent the position of an object in physics, you have to do it in terms of, now the word we use there is coordinates. Now you should be familiar with this term, but if you aren't, let me explain it using a graph, for example. Now when you have a graph, we say that on a graph you have axis, right? So the horizontal axis, often called the x-axis, and then we have the vertical known as y-axis, okay? Any point from the origin O here can be represented with direction, okay? With position, I mean. Say for example, an object is here and it is 2 on the x-axis and 5 on the y-axis. The coordinate of this object, from your knowledge of graph, you will say is what? You write it in brackets, x comes first, that is 2, 5, right? So I hope this refreshes your memory on coordinates. So we look at it as distance from those said dimensions we're talking about, the 3-dimensional, 2-dimensional, 1-dimensional plane we were talking about earlier. So, and in physics we arrange them from x to y and then to z. So we're going to be using just 3 dimensions for the purpose of this lesson. So the coordinates we are looking at for 1 dimension, we use the x coordinate. Okay? For 2 dimensions, you're going to be using the x, y coordinates. And then if you are using 3 dimensions, you'll be using x, y, z coordinates. Okay? And how you would represent it is by the distance from these said positions or coordinates. So if you're using the x coordinate only and you say 5 plus 5x, right? Say for example, this plane, if we extend it this way, you know this would be the positive and this would be the negative, right? So if the object is on plus 5, it means from this origin here, you just have to move 5 steps rather, plus 5. 5 steps to the right, and then you get to the position of that object. You could also have it in the negative side when it goes this way. Let's say minus 2, that is 2 steps left from the origin, okay? And if it is just on the y-axis too, you could do the same thing now. Yes, we use x, we can also use just y, if it is just 1 dimension, right? But if you are using 2 dimension, it means it's not going to be on any of this line, it's going to be in space here, okay? So like this object I just placed here now, it is 2 steps on the x-axis, 5 steps on the y-axis that traces to come to this point, right? So this object is defined from 2-dimensional space, and if you're representing this in physics as well, we use this same thing, that is x comma y, which in this case is 2 comma 5. Okay, and if it's in the 3-dimensional plane too, you do it as x comma y comma z. Now take note, this represents length, this breadth, this height. Okay, so when we're using the z coordinate, it means the object is hanging, okay, while x and y is just looking at it on the floor. Okay, so these 3 helps you to get the coordinates or the representation of the position of an object. So don't forget, depends on the number of dimensions, whether 1, 2, or 3, and we use letters such as x, y, and z to mark coordinates. And this can be represented with numbers, which could be either positive or negative from the reference point known as the origin. So this is how we represent position in physics. Thank you. Now let us look at the meaning and characteristics of distance. Now, the word distance is used when you are discussing motion of an object. Now, though motion is a later topic in physics for SS1 students, but you have already been introduced to this topic at lower classes when we're discussing basic science and technology. Now, to refresh your memory on what motion is, it was probably defined to you as the change in the position of an object with time. Now, if you recall, in the previous video, we looked at positions, right? Now, position is telling you how far an object is from an origin point. Now, we are saying motion is the change in the position of an object. That is, that particular object must have moved from one set position to another set position. Now, when you are looking at motion, you are not just looking at the distance it has traveled. You are not just looking at just that alone. You are looking at the way by which it moves from one position to another position. Those are the things you are considering, how it moves. Okay, and to that you then begin to look at different types of motion. Now, you must have been told about linear motion, rotational motion, random motion, and oscillatory motion. But this topic is not about motion in particular. We want to look at what distance is. I just had to refresh your mind because distance is related with motion. Now, if you're asked to define distance, what does it mean? Distance is looking at the total length of the path that an object travels. Okay? It doesn't care whether it went in a linear motion, whether it's going through rotational motion, oscillatory motion, or random motion. It is only concerned with the length of path that the object has traveled. So say, for example, you move from your house to the school. Okay? And now, those of you that use this device that counts the number of steps you make, you can actually record that as distance also. You can actually convert it, to distance. So when you move from your house to school, there's a number of steps you will take for that distance. But while you are in school, you still move about. You could go from one class to another. You could go for recess. You could go for your break time. All of these involve you moving from one point to another and back again. So you see, you are going through different routes, different paths, and all of these combines to your motion that you go through in just one day. So what distance is looking at that point is the amount of distance you travel, the length of path you pass throughout that day. As you are moving from one point to another, back again, it is recording all of this. And then when you get home, you see that you have gone through 16,000 steps in just one day, or maybe 10,000 steps in just one day. And then you begin to ask, I didn't just go away from this place. I was just in school now. How did I manage to record this number of this? It's because it is recording distance. So let's not go off point. Let's come back to the definition of distance. So like I said, we'll define it as distance is defined as the total. Now, this word is very important to the definition. Total length of path an object travels. Okay, the total. So whether you move forward and back again, it's not concerned with distance. It's just looking at the total length of the path that object travels. Okay, so this is how we define distance. Now there are some things that we have to that helps us to differentiate between distance and other things that has to do with length of path, like displacement. Okay, so that is the characteristics of distance. Characteristics of distance. Now, the first thing you would note about distance is that it's looking at the total length. It's not concerned about whether you move forward or backward. So that means the number attached to distance is always positive. So distance is always positive. Always positive. Okay, and also part of that line, it does not concern itself with whether you move forward or backward. So that is, it does not reduce even when you change your path. So we put that down and say distance does not reduce when you change direction. Okay, so that is, it does not concern itself with direction at all. Another thing you can pick from this is that we can say therefore it is a scalar quantity. Now when we say scalar quantity, these are quantities that have only magnitude. They don't have direction. So they can be understood by just attaching a number and a unit to them. They do not concern themselves with direction. So that is, in one place alone, you could move a distance of 1 kilometer without leaving that spot where you are. You just keep going round and round and round and round and round, and then back to the same point where you started from always, and then you still record a distance because it will calculate the amount, the length of the total length of the path that you go through within that same spot. So I hope you understand what this line means here now. And then thirdly, remember in physics, when you take any measurement, you have to attach a unit to it. That's how we understand measurements in physics. So we say distance is measured in meters. In meters. And the symbol we use here is m. So when you're recording the distance traveled by an object, you get a number and then you attach the unit meters to it. Say for example 5,000 meters, 200 meters, 10 meters, and so on. These are measurements of distance. Now it's important to also say this. Now when you're measuring in meters, we also have multipliers that you could attach. Say for example 1,000 meters is same as 1 kilometer. Okay, and sometimes it could be smaller versions of these distances, like we have in millimeters, centimeters, micrometers, and the likes. Okay, all of these are still talking about distances, but it is important that you know that the SI unit, I remember SI stands for Systemi International, that is the universal standard unit for measuring distance is in meters. So no matter what you're doing, if you want to put it in the standard, you would use it in meters. But you can attach multipliers to it to make it easy to comprehend. Like if you are dealing with small figures, you use millimeters, micrometers, nanometers, and the likes. And if you are dealing with larger numbers, you could use kilometers, you could use even megameters, gigameters, terameters, and the likes. So that brings us to understanding the meaning and characteristics of distances. Thank you. Now let us look at the meaning and characteristics of displacement. Now I mentioned earlier that many students often confuse displacement and distance. Now when you look at these, they are measured in the same unit, so it's easy to actually confuse them unless you truly understand their meaning. So this is why we are looking at the meaning of displacement, and then we'll compare it to the meaning of distance in a later video. So we'll just look at just the meaning and the characteristics in this video. Okay, and please don't forget to like, share, and subscribe. If you're not yet subscribed to the channel, ensure you do so. It's only going to take a second of your time. Just click the subscribe button, and then you can also hit the notification bell icon, so that way every time we put out a new content, you will be notified. And please ensure that you share the videos and encourage those you share them with that they should also be subscribed to the channel, like our videos, and also share it among their list. So this way we can always reach the millions of students that are in need of helpful educational content like this. So please keep sharing. Thank you so much. Now, to get the meaning of displacement, okay, let's take, for example, an object starting from point A. Let's call this place point A. And then it's going to another point. And then it goes by a winding road. Now, as it travels, it goes this part, and then bends, and then back this way, and then like this, and ends up at point B. Okay? When you look at the distance traveled by this object, you will consider the total length that the object traveled through. The length of this part is what you will consider. But when you are looking at displacement, you are not concerned about this. You just look at where has the object started from? Point A. Where did it end up? Point B. Then you join them by the shortest possible length you can get. Okay? Now you see this line that I've drawn from point A to point B represents the displacement of that object. While this part here, this winding part, represents the distance that the object has traveled through. So you see that they are very different from each other, right? So to put this in context, this is how you would define displacement. We say displacement is the shortest distance between the start and end position of an object that moved. Okay, so when an object moves from point A to point B, you can join those 2 points by the shortest length possible, and then that way you get the displacement. Now, this displacement helps to understand a few things. Like, for example, I heard one time where someone was talking about a travel they made. Now, for that travel, a certain number of people first went by a bus to the said location. And then they started their journey in the morning, very early in the morning. The person mentioned, I think, 6 a.m. And then because this other person that he was telling the story had some other things to do, so the person had to stay back a while. And then this other person started their own journey at 10 a.m. Now you see the gap there, that's about 4 hours difference. Yet, the last person to leave got to the final destination before the others. Now this is because this last person to leave actually went by plane, while the others went by bus. Now, many will say the plane is faster amongst other things. One of the reasons why traveling by plane is faster is not just because of the speed of the plane, but the path the plane has to go through to get to its destination. For a plane, all it just has to do is go through the runway, take off, and then find the closest direction, the closest path it could take to get to where it's going. So it just goes by a line. That's all. That represents what? Displacement. Okay, while for the bus, it has to negotiate different turns and bends, go through different hazards on the road before it gets to its final destination. It is equally fast, though not as fast as a plane is, but it can go through distances in a quick time. Okay, but the difference is because it has to go through a series of paths to get to its final destination, unlike a plane that just takes off, sets its direction, and goes in that direction at very fast speed. So you see the difference between these two, right? They can help you understand the differences between distance and displacement. But back to this definition. we say displacement is the shortest distance between the start and end position of an object that moved. Now, you should also know that this means that displacement is concerned about direction. So note it. It is a vector quantity. Unlike distance, that is a scalar quantity, displacement is a vector quantity. Now, what this means is that it is concerned with not just magnitude, but also the direction of the motion. Now, this can help us to now look at the characteristics of displacement. So, let's put that down. Characteristics of displacement. Now, the first characteristics of displacement that I would like to put down is that it can be positive, negative, or zero. So all of this depends on the direction. Don't forget, we say it's a vector quantity, so it is concerned with direction. So for example, if an object starts at this point and then travels a set distance this way and then stops here, this is a positive direction. The displacement will be recorded as a positive displacement. But if the object moves and then comes back passing where it started from, say for example it then comes back this way in this direction and then stops here now, this will be a negative displacement because it has moved back from where it started. Okay, and then if it moves forward and then comes back to where it started, that will be a zero displacement because the object has not moved away from its start position. That's the first characteristics of displacement here. Secondly, is that it is a vector quantity. It is a vector. Okay, and then the third thing is that it is measured in meters. Okay, so you see here that displacement is also measured in meters, which is similar to how distance is measured. So the only way you can tell displacement apart from distance is by direction. Okay, one is scalar, the other is a vector. Displacement requires a direction of motion, while distance does not require it for an understanding of the length of the path it has taken. So this is the meaning and characteristics of displacement. Thank you. I believe now you can define correctly distance and displacement. Now let us look at the key differences between distance and displacement. I'm going to look at 4 features. The type, that is the type of quantity it is, whether it requires direction or not, the value, whether it's positive, negative, or zero, and then the path. Okay, and then I'll give you 3 different scenarios that can also help you to understand more about the differences between distance and displacement. So let's start with type. I mentioned this while we were defining distance and displacement. Recall that I mentioned that distance is a scalar quantity, okay, while displacement is a vector quantity. So once again, what this means is that to understand distance, you just need a number, or in other words, magnitude. So you can understand it by just magnitude only, okay? Whereas displacement can only be understood with magnitude and direction. So that's one of the key differences between distance and displacement. Now, secondly, in the case of direction, just as this rightly points out, distance does not require direction. Okay, does not require direction. Okay, so for you to understand distance, you don't need the direction the object traveled. But to understand displacement, direction is important. Okay, direction is necessary. Direction is necessary to understand displacement. Now, the third thing that we'll use to differentiate between distance and displacement is the value. Now, when measuring the distance of the object has traveled, the result is always positive. Okay, so that is, distance is always positive. It always has a positive value. Whereas in the case of displacement, can be positive, negative, and even zero. It all depends on your start and end point. I did give an explanation of this when we're looking at the definition and the characteristics of displacement. So I said when an object starts from a point and then moves in the forward direction, that would be a positive displacement. If it moves forward and then turns back, that would be a negative displacement when it ends up at the point that is behind the start point. And then if it goes and then returns back to the start point, the displacement in that case is 0. Now that's how you differentiate in terms of value. And then finally, in terms of the path, okay, distance measures the length of the entire path. Okay, but displacement only measures the distance between start and end point. Okay, so to further explain this, let me give you 3 different scenarios. Say for example, if a person moves 300 meters from a point A to another point B, okay, and then turns back and then moves 100 meters back. So that is, start at A, moves to point B, which is a total length of 300 meters, and then returns back 100 meters. Okay, now if you are to measure the distance traveled by this object, you will consider the entire length of the path, and that will be 300 plus 100. That will give you 400 meters as the distance traveled by the object. But if you are to measure the displacement of the same object, you are not going to be concerned about the entire path. You look at where it starts and where it stops. This will now become the stop point, which is point C. Okay? And to get the distance between point A and point C, you will say 300 minus 100, which will give you 200 meters. You see that now? Displacement of this object is giving you 200 meters, while distance is giving you twice of that, which is 400. That's a clear difference between the two of them. Another scenario for you to understand this is an object that is going through a winding path. Okay, I did give something like that earlier. So let's say it starts at point A and then goes along this winding path to point B. Now, if the distance of this entire path is given as, say, 500 meters, to get the displacement, you just need to measure the shortest length between start and end point. And this is going to be considerably lesser than the distance you have measured. You could get this now to be, say, 380 meters. In this case, displacement is 380 meters. So you see a difference there. Distance considers the entire path, while displacement considers a short length between A and B, which is the start and end point. And then the third and final scenario I'll use to explain this, which is often the case when you are solving problems with position, distance, and displacement in physics. Say, for example, an object moves 4 kilometers northward. Now, let me show that here. Let's call this point S. And then travels 4 kilometers northward. Now, north will be a vertical line like this drawn upwards like this. So let's call this point O. And the distance here is 4 kilometers. Okay? And then from point O, it then travels 3 kilometers eastward. So this direction here, and then it goes this way to the east. and this is 3 kilometers. Okay, when you consider this, the distance here, distance traveled, would be this 4 kilometers plus 3 kilometers, which gives you 7 kilometers. However, it's different from the displacement. The displacement here is going to be measured by taking a length, the length of the distance between start and end point. So let's call this end point E. Okay, so you will see that it has traveled north and then east, which forms a perfect 90 degree, a right angle. Okay, and then if we should join S and E by a line, what you have here is a right angle triangle. So let's call the displacement here X. Now to solve X here, we apply Pythagoras. So by applying Pythagoras theorem, square of hypotenuse equals square of opposite plus square of adjacent. So X squared here would be 4 squared plus 3 squared. So X squared gives you, this is 16 plus 9. So X squared here gives you 25, and X becomes the square root of 25, which is 5. So now we see that the displacement is 5 kilometers. And the direction is also important, which is actually in the, as you can see, north. Now this is the direction it's going here. Okay, and this is northeast, the northeast direction. The next thing you just need to find is the angle here. So let's just call this theta for now. Okay, so you need direction and the length of this path here that joins start and end point. That's the key difference between distance and displacement. So please don't forget that if you have any question on this, you can always drop it in the comment section and we will definitely attend to all of your comments. Thank you. Let us now solve questions on position, distance, and displacement. This question itself is saying that a boy walks 6 meters north, turns back, and walks 8 meters south. Find the distance and displacement of the boy. So that is, this question is asking us to find the distance traveled by the boy and then the displacement of the boy. So here is how you solve a question like this. Solution. So the first thing we want to solve is the distance. Now remember that distance is going to measure the total length of the path traveled by the boy. So the distance traveled is going to be, now the first journey it took was 6 meters north, so we'll say 6 meters, and then we add that to the return journey, which is 8 meters, and when we add these two up, what we're going to get is 14. So that is, in total the boy has walked 14 meters. Now second thing we're asked to find is the displacement of the boy. Now to understand this, remember that displacement concerns itself with direction. So let's say the boy starts from point O here. Now it travels 6 meters north, 6 meters, and then return from point, let's call this A, and then goes 8 meters, 8 meters south. This is point A and this is point B. So these are the direction of the motion of the boy. Now you see here that the boy has ended up at a point that is behind where he started from. Okay, so there are two ways to represent this displacement. The first method is to just look at magnitude and direction. So we'll say displacement is going to be now 8 meters minus 6 meters to give you 2 meters, but south of where it started from. Okay, so you can represent the displacement in this form. Okay, 2 meters south, or we just say displacement equals 6 meters minus 8 meters, which will give you minus 2 meters. This tells you that it ends up in a negative 2 meters position from where it started from. So you see, this two tells you the magnitude and also the direction. This tells you is 2 meters to the south, and this one tells you it is 2 meters behind where it started from. That also tells you the direction. Okay, so these are two ways to represent displacement, and with this we have solved this problem. Thank you. Here is another problem on position, distance, and displacement. Now, this question says a person walks 3 meters east and then 4 meters north. Now, we have to find, firstly, the total distance traveled, and secondly, the displacement. Now, this is how you solve a question like this. Solution. So, the A part, to find the total distance traveled, all you need to do is to add the distances that are measured there, because you need the total length of the path traveled by the person or the object. So, in this case, distance traveled would be, now the first part it took is 3 meters east, so that will give us 3 meters. Then we add the length of the other parts, so we have 4 meters north, so we just add it, 4 meters. Now 3 meters plus 4 meters gives you a total distance of 7 meters, and just like that we've gotten the total distance traveled. Now, to get the displacement of this person, displacement would be, first let's draw a vector diagram to help us understand the question even more. So let's take it that the person starts from this point O, and the person travels first 3 meters east. Now east is in the right direction, okay, so that will be this direction here. So I'll put this arrow to indicate the direction. This is east and it is 3 meters. Now from where it stops here, it then goes 4 meters north. So 4 meters north will be vertically upward like so, and this will be 4 meters, meaning that it ends at this point. Let's call that P. The displacement of this person is the length between O and P. So you just have to join O and P with a straight line, okay, like this. Okay, now let's call this displacement S. Displacement S. Now one thing you will observe here is that this forms a right angle triangle, okay, and to get the displacement, remember displacement is looking at both magnitude and direction. The direction of this displacement is in this way, which if you take it on the Cartesian plane, this is northeast. Northeast. So we need this angle here. Okay, we need this angle to be able to get its bearing, because its actual bearing is here. This is the actual bearing. We need this. So let's call this alpha, and then we call this theta. So you start by getting theta so that you can get alpha. Okay, remember that bearing is measured from the north, not from the east. So that is why we are measuring this part to get alpha. Okay, now let's solve this. I'm sure you're familiar with solving questions like this from your junior days in science and tech, and also in mathematics, where you have been taught bearing and distances. But let me just take you through the process once again. So to solve this, we're going to apply the Pythagoras theorem, and that states that the square of the hypotenuse, which is represented here with S, would be equal to the square of the opposite and added to the square of the adjacent side. So that is S squared equals 4 squared plus 3 squared. So if you solve this, we'll say S squared equals 16 plus 9, which is 25, making S to be the square root of 25 to give you 5 meters. Now we have the magnitude, remaining direction. So to get the direction, what do we apply? Remember your trig ratios, okay? From your trigonometric ratio, we need to find theta. Okay, and we have opposite and adjacent. So from your trigonometric ratio, often denoted with this so, ka, toa, okay, where so means sine of an angle becomes opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, while tangent of an angle is opposite over adjacent. So we are using opposite and adjacent. That means we're going to be using the tan ratio. So to do that, we say tan theta equals opposite over adjacent. That is 4/3. So basically, theta becomes tan inverse of 4/3. Now, you can either solve this using your calculator or by using your mathematical table. And when you solve this, you arrive at a value that is approximately 53.1 degrees. So that tells us that this theta here is 53.1 degrees. But from your knowledge of bearing, you know that bearing is measured from the north. Okay, this will be your 0 degree. The east will be 90 degree. South will be 180 degrees. While west is 270 degrees if you are using 3-digit bearing. So to get this angle here, which is alpha, we will have to subtract it from 90. So alpha equals 90 degrees minus 53.1 degrees. And what does this give you? Now the difference between 90 and 53 is 37, right? So remove 0.1 from that and that will give you 36.9. So we have 36.9 degrees. And that is in what direction? This is what? Northeast. So to write the correct answer here, the displacement S will now be, from what we have here, 5 meters. Now for the direction, it will be north. Then this angle, 36.9 degrees. Then east. This is how we get the displacement for this question here. And that brings us to the solution of this problem. Don't forget, if you have any question, you can drop it in the comment section and we'll definitely attend to all of your questions. Just keep them coming. Thank you. Here is another problem still on position, distance, and displacement. Now, this question says, a lorry travels 10 kilometers northwards, 4 kilometers eastwards, 6 kilometers southwards, and 4 kilometers westward to arrive at the point T. What is the total displacement? Okay, so to solve this question, we'll start by drawing a vector diagram. So here's the solution. Now, we could solve this question even without the vector diagram if you're very familiar with solving questions like this. I'm using the vector diagram so that you can see visually what is done. In this case, in this question in particular. So we start at a point here. And note, the lorry travels what? 10 kilometers northwards. And northwards is vertically upwards. So we go from this start point, S, and then go all the way up here. So let's represent this as 10 kilometers. Remember, it's in this direction. Okay, northwards. Now, the question then says 4 kilometers eastward after that. And eastward will be to the right. So from here, we go to the right, like so. And this would be 4 kilometers. Okay? And then at this point, it then goes 6 kilometers south. Now, it can't be as long as 10, so we just bring it. But make sure it's just above half of that. Okay? To this point. And then we say this is 6 kilometers. All right? And then 4 kilometers westward, which is back left. And since this is 4 kilometers, it means whatever we are drawing here has to be the same as this. So it will come back to touch this line. Okay? So meaning this is where it stops point T. Okay? This is 4 kilometers. Now, to get the displacement. Now, take note. If this question were asking us to find the total distance, we would have said 10 plus 4, that's 14, plus 6, that's 20, plus 4, and that becomes 24 kilometers in total distance traveled by the lorry. but the question is asking us to find the total displacement. So which means we're just going to look at the length between the start point and the stop point. So it starts here and then gets to this point. So we need to find this as x. Now, if this is x, we know that here to here is the same length as this. This is 6. And it is these two that makes 10 kilometers. So we start by saying our displacement equals, now to get that, let me use this method instead. Okay, let's add this and say x plus 6 kilometers equals 10 kilometers. Let's use this method instead. So from here we can get our displacement x by saying 10 kilometers minus 6 kilometers. And that will give us just the magnitude, which is 4 kilometers. Now the direction. You see that this part remains on the north direction. It does not shift, right? So since it doesn't shift, it's moving northward. So displacement would then be 4 kilometers northward. Okay, and that will be the solution to this problem. If you have any question at all, maybe during your study time you came across a question that you like some help with, I will be delighted to answer that question for you. So please put it in the comment section and we'll definitely attend to it. And please don't forget that we are trying to reach many students who are in need of helpful educational content like this. So please help us to reach them by sharing this video to those on your contact list. And please help encourage them that they do subscribe to the channel, like our videos, and also share it amongst their own friends as well. This way we can continue to grow our community of learners who are always getting all the necessary help to be better at not just physics but other subjects as well. Thank you for following the video. I hope you've understood the concept of position, distance, and displacement. If you have any question, like I said, please keep them coming. We'll attend to all of it. Thank you so much. I'll be seeing you on the next video. Bye for now.